Good evening, everyone. Welcome back. Biochemistry Simplified. Madam Winnie here. I appreciate every effort each member is doing in subscriptions and viewing. I thank you so much. Keep on subscribing and liking and viewing as well, so that we can move together in this journey of understanding biochemistry. Now, today, I'm going to cover lipids, and in each of these biomolecules which I've been covering, we'll be dealing much with the building blocks. So for lipids, I'm going to cover the building blocks, which are fatty acids. So most of the lipids have fatty acids as the building block. By the time lipids are digested, the resulting products are always fatty acids and glycerol. So on hydrolysis, the lipids will always yield fatty acids and glycerols. So in this case, I'm going to acids, and we are going to mention their classification, as much as we are also going to mention the structures, how we can draw a fatty acid. If you talk about saturated fatty acid, what does it mean? How does the structure of a fatty acid looks like? What are the components of a fatty acid as compared to amino acid, as compared to carbohydrates, which we've already looked at, or the sugars. So in this respect, we'll be able to start by defining what fatty acids are. Of course, most of the lipids have them as the building blocks, and if we looked at the components of the carbohydrates, it was carbon, hydrogen, and oxygen. For the proteins or the amino acids, we saw another component of nitrogen and sulfur coming in. Basically, on the R side chain had sulfurs for the sulfur-containing amino acid, and then for the basic amino acid, the nitrogen was a component, as well as the amino terminal end of an amino acid had a nitrogen. So for the proteins, we had a nitrogen and a sulfur coming handy. Now, for the fatty acids, we'll be able still to have carbon, hydrogen, and oxygen, but we are going to have a carboxyl terminal end and a methyl terminal end. So the carboxyl terminal end is the one which has a polar carboxyl group. They talk much about a polar carboxyl group. So they are the building blocks of lipids, and they're made of long chain organic acid. It means they're always soluble in organic solvents. And then they have the polar end, which is the carboxyl group, is known as the head, and the non-polar end, which has the hydrocarbon chain. So we'll always have a methyl end or a methyl side, which is known as the tail. It's always hydrophobic. So the tail makes it water insoluble. So they are not found free in nature, but they always exist in esterified forms. So if you talk about the ester bond that is found in lipids, you talk about a peptide bond, which was found in proteins, and then we talked about a glycosidic bond, which was found in carbohydrates. So we are going to find the number of most fatty acids, they exist as even chained. So if you talk about the even numbers, the numbers which were divisible by 2, whatever we learned much in primary school. So the 2, 4, 6, 8, 10, 12. So most of these fatty acids are even number of carbons. They have even numbers. So they are classified as saturated and the unsaturated. So for the saturated fatty acids, if you look at their structure, there is no double bond. And then for the unsaturated, there is a double bond. Then under the unsaturated, we have the monounsaturated as well as the polyunsaturated. So from the name, the monounsaturated, they have at most one double bond, or you can say it only has one double bond. But for the polyunsaturated, at least two and above. So we talk about polyunsaturated. fatty acids. Now for the unsaturated fatty acids, as much as they have a double bond, but the double bond it's always between carbon atom number 9 and number 10. So we talk about unsaturated having double bond present, but most of the double bond will always occur at the 9th carbon. But you have to count from the carboxyl terminal end so that you can position where the double bond is. So the counting of the position of the double bond, you will start from the carboxyl terminal end. Mostly the carboxyl terminal end is always on the right hand side. Then the left hand side we have the methyl group. So we have two classes. It's either saturated or unsaturated. The saturated, there is no double bond. We are going to see an example of such and how to draw them. And then for the unsaturated, there is a double bond. But still under unsaturated, we have the monounsaturated and the polyunsaturated, of which the monounsaturated will always have at most a bond, as the polyunsaturated will have 2 or more, or at least 2. So for the saturated fatty acids, we've said there is no double bond in them. An example of such, if you talk about animal oil, we have meat, we have milk, we have butter. Those are examples of saturated fatty acids. And then we have vegetable oil, of which we give an example of a coconut or the palm oil. So if you have to draw the saturated fatty acids, I'm giving options on how to draw them, but the simplest one is to align them in a linear way, whatever you are seeing here. So in this case, I have a saturated fatty acid. In the structure, you can see there is no double bond. On my right hand side is a carboxyl group. There is a OH here. The H has just been slashed out, but it's a COOH this end, and then the methyl end you have CH3. So they are included in counting of the number of carbon atoms. So in this case we have 18 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and then the 18th one. So the 18th one is the methyl group. The first carbon is the carboxyl group. Then in between, I said around the carbon, we have to balance the bonds, because if you go by the configuration using the atomic number of carbon as 6, the configuration goes to 2 to 4. So the outer shell need 4 electrons for stability. So that is why around our carbon, we need to balance it using the 4 bonds. So you can see around the carbons, we have to balance them. So this is the simplest way we can draw a C18 colon 0. So we talk about C18 being it is 18 carbon atoms, including the carboxyl terminal end and the methyl end, and then we are talking about C18 colon 0. The colon will always separate the number of carbon atoms with the number of double bonds. In this case, we have C18 colon 0 because we have 18 carbons and 0 double bond, meaning no double bond. So in this case, the common name is always known as stearic acid. So for somebody who is a starter, it's easier to draw it in this way. You draw the linear, all the carbons arranged in a linear order, then balance with the hydrogens in between here. You'll have C18 colon 0, meaning it is carbon 18 carbons, no double bond or 0 double bond. And the common name of that is stearic acid. We are going to see a table with the common names. But now this slide tells us how we can draw it. Draw, giving the carboxyl terminal end to your left hand, to your right hand side, sorry, and then you have the 18 carbons. To the left hand side, you have the methyl end. Same, you can also draw it the same way as whatever you are seeing down here. You just have those ticks, you can see those lines. So it tells you this carbon atom number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8, number 9, 10, 11, 12, 13, 14, 15, 16, 17, and then the 18th one. You can also easily draw it like this. Either way, the one which you find easier is the best. But then these are based on the number of carbon atoms. It is a saturated fatty acid, no double bond. So in that case, we talk about C18 for this example, 18 of them, carbon atoms, 0 double bond. So on my right hand side, you can see the same, that is stearic acid, the same which is drawn here. Down here we have palmitic acid as well, the palmitate. This is known as the stearate. So the palmitate is always C16 colon 0. 16 carbon atoms, 0 double bonds, having the carboxyl terminal and the methyl end this side. So here we have a methyl group. A methyl group is here, and we can also include it. A methyl group, I'm not good in how these things draw, but we can try. Methyl group is always on our left hand side, then on our right hand side we have the carboxyl group. So you can draw it like this. So the lower one is palmitate or palmitic acid, the upper one is stearic acid, and the stearic acid is the same as the one which we have to our left. So you have, this is the carboxyl terminal end. The hydrogen was left out, but it should be like this. So you have the carboxyl terminal end, the carboxyl terminal end, and the methyl end on my left hand side. So the carboxyl terminal end, as I mentioned in the introduction, is the polar part, and then this other part is the non-polar, or is what makes them insoluble in water. So that is the methyl part. So if you look at the structure of fatty acid, you have the methyl end, and the carboxyl end. So that is how the structure of a fatty acid looks like. So we have the methyl end, we have the carboxyl end, but remember, when you are going to count on how to place the double bond, you count from the carboxyl terminal end. The methyl and the carboxyl terminal end are included when you are counting the number involved in the formation of our fatty acid. So we have the unsaturated. Remember, we had the saturated and the unsaturated. So the unsaturated, we mentioned that they have a double bond. It's either monounsaturated or polyunsaturated. For the monounsaturated, at most one double bond, or just say it has a double bond. If the at most and at least will be bringing a lot of confusion. Monounsaturated, you have only one double bond. For the polyunsaturated, it's 2 or more. It means at least 2 double bonds. So when we are drawing our structures, it can show C18 colon 1 delta 9, meaning our fatty acid has 18 carbons inclusive of methyl and carboxyl end. Colon separates the number of double bond with the number of carbons. So it has 1 double bond. The delta will indicate the position where the double bond is. So it says at position 9. So it means after carbon atom number 9, you have to count from the carboxyl terminal end, remember. After carbon atom number 9, place the double bond. And when placing the double bond, remember to balance the bonds around the carbon. So it says it is 18 carbons, our fatty acid, 1 double bond at position 9. So if there is no delta, then there can also be bracket explaining the position of the double bond. So the delta will indicate the position of the double bond. The next number will show the number of carbons. I don't know whether it's next number reverse or next number forward, but then this is the number of carbons, this is the number of bonds, but then this is the position of the bond. So in a different way, the position of the bond can be indicated as shown in the second expression without the delta, this one up here. So 18 indicates 18 carbons, 1 indicates the number of double bond, the delta 9 indicates the position of the double bond. So it will have to be between 9 and 10. So in the unsaturated fatty acid, there is a double bond, and we'll always talk about monounsaturated and polyunsaturated. For the monounsaturated, at most one double bond. The best example, we have the avocado, the olive oil, together with the peanut oil. They fall under the monounsaturated. Then the polyunsaturated, at least 2 double bonds, and they're the ones which are also known as essential fatty acids because they are required in the body and the body can't synthesize them. So they have to be included in the diet. So example of those two, polyunsaturated fatty acid or essential fatty acid, we have the linoleic and the linolenic. So the linoleic, that is the common name. Linolenic, common name. But for linoleic, remember, it is 18 carbons, 2 double bonds at position 9 and 12. So it means as much as it is 18 carbon atoms, whatever you are seeing here, this is linoleic, the one with 2 double bonds. You place the double bond starting from the carboxyl terminal end. Count from the carboxyl terminal end. 1, 2, 3, 4, 5, 6, 7, 8, 9. After the 9th one, there is a double bond. After the 9th one, 9 and 10, there is a double bond. 9 and 10. So when there is a double bond, you have to balance the hydrogens around the carbon where the double bond is. Then you go to 10, 11, balancing bonds around the carbon. 12, remember it was between 9 at position 9 and 12. So it is 9 and 10, 12 and 13. So 12 and 13, there is a double bond. Balance the bonds around the carbon so that the double bond will now have only 2 of the hydrogens attached to the carbons. Then 13, 14, 15, 16, 17, 18, and 19. So the methyl end, they always refer to it as the omega side or the omega end. This one is always the alpha end. So we always have the omega end, which has the methyl, and then we have the alpha end, which has the carboxyl. So when placing, make sure that you count from the carboxyl terminal end. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9. After the 9th one, put a double bond, balance with the hydrogen. 10, 11, 12th, put a double bond between 12th and 13th. Then you balance with the hydrogen. That is linoleic. Then linolenic is also polyunsaturated. It's also one of the essential fatty acids. You can see it has double bond at position 9, 12, and 15. So you talk about 1, 2, 3, 4, 5, 6, 7, 8, 9. Put a double bond. 10. We are going to have a double bond between 9 and 10, 12 and 13, 15 and 16. So that is 9 and 10. 11, balance with the hydrogens. 12, double bond again, and 13. 14, no double bond, balance the hydrogens. 15 and 16, another double bond, and then we have 17 and then 18. So this is linolenic. We have the alpha side and the omega side. So sorry, this one is a polyunsaturated fatty acid. The common name is linolenic. It is 18:3 delta 9, 12, and 15. Most of those oils in the shops or in the supermarkets, you will see they talk about it has a component of omega-3, omega-9, omega-6. Where does the name come from? The omega-3, omega-6, and omega-9. It means after you have placed your double bond, remember placing the double bond comes from the carboxyl terminal end. But now, when you have to give name to this first one, which is linoleic, if you look from the methyl end, you count first, second, third, fourth, fifth, and then the sixth one. The carbon where you come across the first double bond is carbon atom number 6. So this is omega-6. The linoleic is the omega-6. Where you first come across the first double bond, if you look at your structure, it is the 6th carbon atom. Now, this one, the third carbon is where you can see the first double bond appearing. So it is known as omega-3. Then omega-9, as much as it's not here in the example, but you can see it's above up here, where you come across the first double bond. The omega-9 is the oleic acid here. It is monounsaturated. So you come across the first double bond at carbon atom number 9. But when the bond was being placed, you count from the carboxyl terminal end. So this one is monounsaturated. It is known as oleic. You place the double bond at position 9. So it is between 9 and 10. It is monounsaturated fatty acid because it will read 18:1 delta 9. 18 carbon atoms, 1, 2, 3, 4, 5, 6, 7, 8, 9. Place a double bond. 10. Move along again. 11, 12, 13, 14, 15, 16, 17, 18. So the oleic acid is monounsaturated. It will read C18:1 delta 9. Monounsaturated. Its name will be omega-9 because from the methyl end you count the carbon where you first come across a double bond will be at carbon atom number 9. So this is omega-9. This is omega-9. This one is omega-9. This one is omega-9. The first carbon from the methyl end where you first meet a double bond. That is where the omegas come from. This is omega-9. This is omega-9. This is omega-9. So that is the name of this one. This one we already saw. It is omega-6. 1, 2, 3, 4, 5, 6. Omega-6. But when placing the double bond, then you have to place by counting from the carboxyl terminal end. So it means the double bond will come between 9 and 10 for linoleic, then 12 and 13. That is how simple drawing the structures are. So whichever is simple for you to draw, but then you can choose the formula to the left or the one to the right. You will still get it right as long as you will be able to draw the correct structure. You will get it right. Then we have another polyunsaturated, but then it falls under semi-essential fatty acid. It is known as arachidonic acid. Arachidonic acid is 20 carbons, 4 double bonds, at position 5, 8, 11, and 14. So it is semi-essential because it can be synthesized from linoleic and linolenic fatty acid. So it is semi-essential fatty acid. So we've seen the poly unsaturated, we've seen the mono unsaturated, we've seen the saturated fatty acids, and how you can draw the fatty acids. So if you 0, you will know this is saturated fatty acid. C14 colon 0, that is saturated fatty acid. C16 colon 0, saturated fatty acid. 18 0, saturated fatty acid. 20 0, saturated fatty acid. 24 0, saturated fatty acid. So the colon separates the number of carbons and the number of bonds. So they have 0 double bond. They don't have any double bond. So we name them as saturated fatty acid. So you can also draw structure in this way. Which one is easier for you? No problem, as long as you draw it correctly. But you have to know that when you are drawing it in this way, you have to separate the carboxyl terminal end clearly and the methyl end. So if you separate the carboxyl terminal end, for example, for this common one known as lauric acid or laurate, carboxyl end already 1 carbon, methyl end the second carbon, 2 minus 12, you are remaining with 10. So the CH2s, you'll put a bracket 10. Then for C14 the same, COOH 1 carbon, CH3 second carbon minus 14, you'll have CH2 bracket 12 until you reach the 24th. So they have the common names. Leave alone the systemic name. It can be a bit complicated. We always use the common names. They always exist with their common names. The structures, which now we have the third version of the structure. You can draw any, the one which you understand better, as long as you draw it correctly. But based on the number of carbons, structure, and the common name, you can see C12, 0 is lauric acid. Myristic acid or myristate is 14, 0. 16, 0 is palmitic acid or palmitate from the palm tree. And then we have stearic acid, which is C18 colon 0. And then we have 20, 0, known as arachidic. You know, the saturated one was arachidonic. The saturated of palmitic was palmitoleic. So arachidic comes as a saturated form, 20, 0. Then we have lignoceric, 24, 0. Then you have 16 colon 1 delta 9. 16 carbons, 1 double bond at position 9. Then you have another one, 18 carbons, 1 double bond at position 9. So in that case, you have 16 colon 1 delta 9. You will have palmitoleic acid. They already added palmitoleic, or leic is already added there, so it shows it is saturated fatty acid. Then you have the carboxyl terminal end, COOH. But then before you reach the position of the double bond, this is 1 plus 7, 8, then the 9th one, there is a double bond between 9 and 10, then you have 15, then CH3. Sorry. So as long as you will be able to balance your bonds, it is fine. We have 18 colon 1 delta 9, 18 carbon atoms, double bond at position 9, but then it's known as oleic acid. So the double bond is between carbon atom number 9 and number 10. We have the poly unsaturated fatty acids now. 18,2 delta 9, 12, 18,3 delta 9, 12, and 15, 20 colon 4 delta 5, 8, 11, and 14. So this is the one which had the common name linoleic. the one which we refer to as omega. This is the one we refer to as omega 6. Then 18, 3, 9, 12, 15, linolenic. We refer to it as omega 3. So the common name is linoleic. You just place the bonds, double bonds, around carbon atom number 9 and 10, 12 and 13 for linoleic. Linolenic, place the double bond at position 9 and 10, 12 and 13, 15 and 16. Then for arachidonic acid, 4 double bonds. You'll place a double bond between 5 and 6, between 8 and 9, between 11 and 12, and lastly between 14 and 15. But we have to bear in mind that for you to draw a fatty acid, the carboxyl terminal end lies to the right hand side, the methyl end lies to the left hand side. When placing the double bonds, count from the carboxyl terminal end and place your double bond after the carbon which bears the double bond.